For test 3, the problem I had the most struggles with was the second problem, discussing rotations. I got part 1 just fine, so I'm going to write that out just for remembering and using for part 2 of the problem, which is where I got 0 out of 20 points, simply because I didn't understand how to start the problem or how to go about the problem. So I'm putting in that final velocity in terms of variables from the first part of the system, or from the first part of the question. And then beginning on part 2 of the problem. I started with just writing out what I needed to achieve from this problem, so I know that I needed to use the extended energy system to find the angular speed. So started out with the change in energy of the system extended, and then realizing that I can use the change in kinetic energy, the change in translational kinetic energy, and the change in rotational kinetic energy to equal the final work. And then it's a matter of just plugging in the formulas for translational kinetic energy and using the variables from up top, remembering that all of the masses need to be accounted for, and then the rotational kinetic energy, which deals with I, inertia, and omega. And here we're looking for omega. And then it's just a matter of solving for omega, so it's just the algebra of rearranging the equation, keeping I as it is for now, just to rearrange this all together, and then later we will just plug I in to this rearranged equation. And here, since this is a cylinder rod, that means that I will be 1/2 mr squared, plus accounting for the 2 point masses themselves being together them being 2m times L/2 squared. And then we will use this I and plug that in for I in the original rearranged equation for omega. And from there, that is essentially the correct answer. After this, I did end up simplifying that into the final answer for omega, which is root 4 of s over big M r squared plus little m L squared. And that is our final answer.